Blind from birth, Daniela Levy-Pinto, a doctoral candidate at the University of Toronto, is about to demonstrate some of the common shortcomings found in current accessible GPS devices. Problems with GPS begin right out of the starting gate. The path from the front door to the city's sidewalk is not marked on any electronic map, so until Daniela makes the turn, she's in her guide dog Luke's hands, or should we say paws. Daniela got lucky today, and Luke did the trick beautifully. But this unmapped problem illustrates the critical flaw in present GPS devices. Marking the path and turn would be futile, for a GPS reading with a 10-meter error would push Daniela right across the street. The sighted, whose immediate environment is always in view, don't need a greater degree of accuracy. Daniela is using an iPhone 4 with an application called Sendero, Look Around. It's the third device she's used in the last 3 years, and she likes its out-of-the-box voice, simpler controls, and built-in GPS antenna. But like all mobile phones, important commands must be keyed in. With a harness in one hand and a handset in the other, this can be distracting and sometimes hazardous. Walmer Road is a relatively quiet residential street. She knows it well and needs little help from GPS to navigate. If Daniela's daydreaming or distracted, however, Look Around does a good job of telling her the adjacent street addresses, the distance to the nearest intersection, and her heading. But if the GPS satellites are having a bad hair day, well, the system could put Daniela on the next block. The 10-meter gap in accuracy becomes more significant as we approach a busy intersection. Since the city leveled the curbs to accommodate wheelchair traffic, some guide dogs have difficulty finding the curb edge. Even when it is detected, they can find it hard to navigate a straight line across the intersection, given its wave of crossing pedestrians. If we could accurately locate and map the curb lines, the crosswalk parameters, and detect the light changes, safety and confidence could be greatly enhanced. Currently, there are at least 3 mobile phone vendors, Nokia, Google, and iPhone, that provide some degree of GPS accessibility, but they're only as accurate as the GPS signal and won't work indoors. Ironically, most electronic mapping systems boast centimeter accuracy, and some make provisions for adding valuable personal routing information, such as bus stops, traffic lights, and doorways. But unless we bring down GPS error from 10 meters to 1/2 meter, there's no real advantage to incorporating these important pathways and destinations into their maps. Another challenge is hands-free operation. All mobile phones currently require some degree of manual input. And on a cold and rainy day, with a dog or long cane on one hand and a handset in the other, the task, as we've mentioned before, can be dangerous. Earbud-type headsets would be helpful, but most of the visually impaired find that ear canal blockage interferes with their echo perception. We would like to say that Luke's problem in getting Daniela into the U of T bookstore is uncommon, but it still happens all too often. That's why we're working to improve this technology so that our clients can move confidently from the street through the front door to their final indoor appointments without the assistance of kind strangers. Synthetic Imaging Research, Inc. is meeting the technological challenges demonstrated by Daniela. In collaboration with the Inclusive Design Research Center and OCAD University, we're designing a system capable of identifying nearby objects with centimeter-scale accuracy.